Advanced Router Technology Part 1, Routing the Unroutable with Routing Bridging Technology. Have you ever laid out a network diagram of your network and saw all the routed points around the network and thought to yourself, boy, this would all be easier if these routers just went ahead and passed broadcast traffic back and forth uninhibited? Me neither. But that's what bridging really does, is it takes all the interfaces of your routers, or the selected ones, and bridges them together as if the router was never existing in the first place. And you might think to yourself, well, why on earth would I ever do that? Well, there are instances, typically in older networks, where you may need to bridge multiple network segments together even though they're attached with a router. The good thing is the router gives you additional functionality that you may not find on some of the older switches out there. So we're going to start this section off talking about transparent bridging. That's one of the most common ways that we can bridge our Ethernet segments together, and then we'll enhance it with a new interface type, and I'm excited about this section: integrated routing and bridging. There is actually a new interface that we can create on our Cisco router called IRB interfaces. These are invisible make-believe interfaces that the router can use to route the bridged segments. I know right now that sounds pretty wild, but once you see a network diagram of how this thing works, you'll be blown away. And then finally, while not a true bridging technology, I'd like to talk about IP helper addresses. It's one of the most common ways nowadays that you can allow some broadcasts to go across a router without allowing all of them. And I just had a situation on a healthcare network that I designed where this thing was used in a way that I would have never thought it used. So I'm really excited to share that scenario with you. And when we get to the IP helper addresses, I'll spell that all out. Well, let's start things off with transparent bridging. I'd like to give you a brief overview of what it's all about, and then we'll get into the full configuration. That's where we'll spend most of our time. A lot of the early protocols were designed without any explicit network layer addressing. They didn't have layer 3 IP addresses and IPX addresses like we have today. They only worked at layer 2 using broadcast messages. Some of those protocols include SNA, IBM's system network architecture, that are used in a lot of mainframe environments. You see on the screen NetBEUI. That was Microsoft's flagship protocol. A lot of people dinged them for it, and I don't know why. It was a great protocol, but it was bandwidth intensive. It only worked at layer 2 using broadcasts. You have NetBIOS, which is still in use in a lot of Microsoft systems today for name resolutions. You'll find your Microsoft system doing broadcasts, NetBIOS-based broadcasts, to try and find other systems and communicate with them on the network. And then DEC came out with a common one called LAT that they used in a lot of their printing devices, a lot of their printers. It's LAT, and it was used to communicate with printers, to find printers on the network. So a lot of these protocols, elder protocols, we could say, that aren't in widespread use anymore, but can be found in some environments, cannot communicate through a routed system. So transparent bridging does simply that, allows those protocols to communicate through it. It will turn your router into a switch for the interfaces of your choosing. As you choose interfaces, for instance, let's say on router 3 we have fast Ethernet 0 over here and serial 0 up here. As I choose those interfaces, I will assign them to what is known as a bridge group. And this is where I'm going to kind of turn it into the configuration side of things. By assigning these into a bridge group, they will be turned into switch ports. They will even go so far to run spanning tree protocol, going through the different port states of blocking, listening, learning, forwarding, just like the spanning tree protocol defines. Now, before I get into the configuration, let me first off answer a question I'm sure is rolling through some of your minds. You're looking at the network diagram going, Jeremy, would you ever find a network that is putting Windows 98 machines on there running only NetBEUI and then splitting them up across the wider network connection? My answer is no. You would never find a production network that would do this. However, I have found in my experience that Windows 98 machines running the NetBEUI protocol are considerably less expensive than purchasing a mainframe environment with terminals on the other side. Using NetBEUI, we can simulate a good broadcast protocol and test our setup. That's the key. You want to be able to test this out so you can verify that it's working. Sure, you can execute the commands, but you're not sure until one device starts communicating to another. And because I know it's a pain to install Windows 98 machines, I'm also going to tell you, as we get into the configuration, how to set up the NetBEUI protocol on Windows XP, because you know they've removed that protocol from the general deployment, but they've given you the files to add it back in, and I want to show you how to do that as we take a turn to the configuration. I went ahead and shrunk down the live demo topology so we could squeeze everything on the screen. And before we get going with the configuration of this transparent bridging, let me show you how to enable NetBEUI on Windows XP so you don't have to reinstall any machines with Windows 95 or Windows 98. It'll save you some time. I'm going to bring up my directory listing of my Windows XP CD-ROM. You'll need your original CD. And underneath there is a value add folder. If you double click that and then jump under the Microsoft or MSFT folder, you'll see this folder called Net. Under that, you will find another folder called NetBEUI. They hide it. They don't want you to use it. So I double click it, and you see two files here, nbf.sys and netnbf.inf. If you open this text file, it will tell you exactly where to put them. You can see copy this folder into your system root, system 32, etc. You just follow these directions and then install the protocol using your network connection properties. If you would like full connectivity with NetBEUI, and I mean you want to be able to start copying files from this machine on the left to this machine on the right and transferring over the WAN link, which could take a while if your clock rate's low. I would suggest adding NetBEUI and then removing TCP/IP from both of these computers. The reason I say that is in some cases, not all of them, I found that TCP/IP actually goofs it up because the system constantly tries to prefer TCP/IP and doesn't even try to use NetBEUI when communicating. So installing NetBEUI will generate enough traffic to where you'll be able to see these things showing up and MAC addresses showing up in your bridge groups, and I'll show you that when we configure this live. But to fully configure it, I would remove TCP/IP as well. All right, let's go ahead and set up the router side of things now. I'm going to jump on router 3, which is over here on the left-hand side. Setting up transparent bridging on the routers is really easy. 2 commands is really all you'll need. I'm sitting on router 3. I'll do a flyby view of the interfaces. And first thing I notice is Ethernet 0, which is plugged in over here. Oh, and by the way, let me show you how I have this set up. Ethernet 0 is actually plugged into a switch that connects to my whole house. So the computer I'm speaking on and I'm using right now is able to communicate with router 3 on Ethernet 0. This one over here is a laptop that I have plugged in using a crossover cable directly in router 2, which is sitting in the other room. I do that and leave it there because I don't want to sit in that room with all those routers on because it gets to 100+ degrees. No fun at all. So I kind of control that one remotely, and this one I'm sitting on right now. So with that in place, on router 3, notice there's no IP address on this interface because I don't need one. That's running NetBEUI. It's not communicating with IP. First command, from global config mode, I type in bridge followed by my bridge group number. And this is just any number that you want to pick that uniquely identifies the group, but you need to use that same number throughout your network as you create the rest of your bridge groups. So I'll just pick 50. From there, the one command we have to issue, and you see a number of commands here, most of which you won't even need to mess with. The one command we need to issue is protocol, because we need to tell it what type of spanning tree protocol to enable. There are actually a few different flavors of spanning tree out there. DEC was the early inventor of spanning tree, and they created their own flavor, and that was what contributed to what the industry standard is now, and Cisco still supports their old standard. IBM created a standard of spanning tree that runs on token ring networks, and this is the one that we want to use, IEEE. VLAN bridge we'll be using if we want to do transparent bridging between VLANs on switches, but this is the industry standard that everybody knows and loves, so you'll always be typing in bridge 50 protocol IEEE. From there, we go under the interfaces that want to participate in the bridge. Interface Ethernet 0/0, and I just type in bridge-group 50. And then it will be serial 0/0, and I have a sub-interface there. It's .1. And I'll also type in bridge group 50. I'm done. On router 3, I've now set up transparent bridging, so it's included this Ethernet interface and this serial interface on the wide area network connection. Now here's a big catch. A lot of people will just jump over to router 2 and do the same thing and think they're done, but not good on this frame relay network. Router 1 is the hub of the network. Those broadcasts will start coming up through router 3, reaching router 1, and if it's behaving like a normal router, it will drop them. You need to also include these two interfaces in the bridge group, and there's an extra bonus command I want to enable on router 1 as well, so let's jump up there. I'll clear off the screen so we have a clean slate to work with. I'm going to get into the global config mode, type in bridge 50, thinking bridge group, protocol, IEEE, and enable that. Now here's the bonus command, bridge 50, and I'm going to type in priority. What this is the spanning tree priority for the router. These routers, like I mentioned in the concept slide just a moment ago, these routers are running full spanning tree. One of them will be selected as the quote-unquote root bridge of the network, and by golly, I want the fully connected router, I want the one with the most connections, which in this case is router 1, it's the hub, to be my root bridge. In this network, it's not that big a deal because there's not many alternate paths that they can go through. But in a large network, you always want to make sure that center router, the central router, is the root bridge. So in this case, I'll just say 100. That's a really low priority considering that the default is 32,000 something. So the other routers, I'm going to leave at the default of 32,000. This one will become the root. I'm going to go under interface. Oh, I'm in global config. Interface serial 0/0.2 first. I'll type in bridge group 50. I'll also go under interface, and I'll talk about that status message in just a moment. Serial 0/1 and type bridge group 50. This popped up and said a random spanning tree identifier address of this has been chosen since there's no MAC address for the selected interface. We didn't get that on router 3 because we included an Ethernet interface which had a MAC address in the bridge group. So it said, oh, I'll use that MAC address for spanning tree, because if you remember, spanning tree has that bridge ID and the MAC address that it uses to choose the root bridge. We just set the bridge ID to be 100, but it doesn't have a MAC address. That's part of the industry standard. You got to have one. So it will just generate one that it will use for this router, since all we're doing is enabling it on serial interfaces. If you have an Ethernet interface, you'll never see that message. So with that, let's jump on down to router 2. That's over here on the right-hand side. And do the final commands. Let me clear the screen off so I have a nice clean slate. It's my habit on each one of these routers. Think of it as Bob Ross, the painter. I'm going to add some happy commands to this router syntax. I'm going to jump on router 2, quick show interface. You notice again, no IP address assigned at Ethernet 0. And I will get into that. Oh, actually, before I do, bridge 50. Protocol, IEEE, and I'll jump onto interface Ethernet 0, bridge group 50, interface serial 0.1, bridge group 50. That's all there is to setting up bridging, and we should have full bridging connectivity across the slides, or across the diagram in the background. Now, I haven't found any good debug commands to use with transparent bridging. All of the debug commands, which will actually show live traffic going across, just return a ton of gibberish because they're returning bit values and things like that. There's two good show commands that you can use, and I'd like to do that now. Let's jump on over to router 3. That's connected to my main network, so it should have some traffic by now. The first command is show bridge. Show bridge will show you the MAC addresses that it's learning from that Ethernet segment. And sure enough, right here, it's already found my MAC address. This is the machine that I'm working on now that's running NetBUI. Everything else is running TCP/IP isn't sending any layer 2 broadcast-based traffic. This one is, and it's found it. It's received 2 packets so far. Not a very chatty NetBEUI machine, but nonetheless, I see that MAC address showing up in the list. The other show command is the show spanning tree. Show spanning tree on a router, that's right. Show spanning tree, since it's now a quasi switch, will show you your bridge group 50, and you'll be able to see all the timers and everything like that the bridge group 50 is running. You'll also be able to verify what interfaces are included in bridge group 50. You see Ethernet 0/0 over here and serial 0/0.1. Between those 2 commands, you should be able to verify that transparent bridging is working. Now, I've been using computers to generate traffic and show MAC addresses in the table and so on. But when you are doing your lab, I know I showed you how to do it, and it's neat to do, but I'd recommend against doing this, setting up computers with NetBEUI, and here's why. You can do it and you can make sure that it works, but when you get to that CCIE lab and you're sitting there with a rack of routers running, you're going to need to be able to configure transparent bridging or other types of bridging, which I'm going to talk about next, without verifying it fully. You won't be able to see the MAC addresses like I just did when I did that show bridge command. The main command that you'll be able to use, and show bridge, let me just show you that command again. Show bridge, it finally fell off, my MAC address, will typically show up like this in the CCIE lab. There's no MAC addresses, no traffic is being generated. And that really is useless at that point. The big command is that show spanning tree, so you'll be able to verify that it is recognizing the bridge group, it is running, and you can see what interfaces that it's including. There is no real way to test transparent bridging when you get to the CCIE lab. That's why I say, you know what, probably not even worth your time to set up these machines, because you won't be able to when you get to that environment. So with that, let's turn our attention to integrated routing and bridging and add some routing aspects to this network. Now, when I first saw transparent bridging, I asked this statement right here. I said, but I thought I bought a router. If I wanted a transparent bridge, I would have bought a switch and connected those together. Now, I know routers add the wide area network component that gives you that true transparent bridge over a wide area network link, but this is a router as well, so it should be able to route, right? Well, it absolutely can. And I took the topology and focused in on just router 3 and added a few more interfaces to demonstrate this. Router 3 has 3 Ethernet interfaces. 2 of them have computers, and if we look at the IP address, 172.16.5.10, 172.16.5.5. These 2 are the same subnet. So I need to create a transparent bridge that gets these 2 interfaces working together. And that we can do using what we just saw. We would create a bridge group of, we'll say 50, just like we did in the live demo a moment ago, and that will bridge those together. And now our computers are happily communicating between each other just fine. But what about when it's time to communicate with this one? What do they use as a default gateway? I mean, do I assign the IP address here? Do I do it here? Will it even accept that if I get an IP request? Because, I mean, this is a bridge. It's not expecting directed communications with IP. It's thinking of broadcast-based protocols. What's going on? Well, here's what's going on. There is going to be an interface that you will need to create, and it integrates with integrated routing and bridging. It is an interface called a BVI interface. It stands for a bridge virtual interface, and here's what we would do. Let me grab my text tool here. I would assign this BVI interface the IP address of 172.16.5.1 with a 24-bit mask. Now, where does that interface reside? Is it a physical interface? How's it get there? Well, that interface is nowhere and everywhere at the same time. These computers can communicate with it because this router thinks it now has a virtual interface that is plugged into both of these Ethernet segments. They can go ahead and now ping that interface. So let's say these computers, for whatever reason, grab my right tool, needed to communicate to each other using, we'll just say Apple Talk, just to throw an example out there. But once they wanted to go across the network and reach this guy on 192.168, or maybe you even have a WAN link up here going off to Paris that has the 10 subnet, 10.x, Whenever they want to get outside, then they'll use directed IP communication. So I'll just write Apple right here, Apple Talk. Here's how you would set this up. Again, the configuration isn't very bad at all. It's the concepts that you need to grasp. I'm going to get into global config mode and type in bridge IRB. That enables integrated routing and bridging. The current iOS that I'm using also generates this command, which I plan on telling you in just a little bit, but since it popped up, I might mention it right now. By typing in bridge followed by the bridge group identifier, we configured bridge group 50, so it says you must be using bridge group 50. It's going to say route IP by default. Now we can disable that, but what that says is that bridge virtual interface, which we are yet to configure, will be able to route IP. It will not route any other protocols. So again, I'll talk about this command once we get that BVI interface up and running. So let's do that. I'm going to type in interface, followed by this new interface type, BVI. And then you have to type in the interface number, which should match your bridge group. I shouldn't say should match. It has to match, otherwise it won't work. I'll type in an IP address. You notice it suddenly came up. It's a magical interface. IP address 172.16.5.1 with the 24-bit mask. I can see it in my show interface command as it sees it as a real interface, and it will keep it around for any Ethernet interface that is added to bridge group 50. Now once I've done that, what I need to do is get into here, global config mode, and I'll type in bridge followed by 50. And then there's two commands. There is route and there is bridge. I can type in bridge 50, focusing on bridge group 50, and bridge lets me tell it what protocols I would like to bridge. Because, by golly, I mean, do I really need to bridge IPX or DECnet if I'm not running it at all? No, I don't. Unfortunately, I just realized it. This iOS version that I'm running does not support Apple Talk, which is my whole example. So I'd have to upgrade the iOS version to get Apple Talk to show up in this list, but there is an iOS version out there that does it. I'll tell you what, let's say instead of Apple Talk, because who uses that anyway, let's say I want to bridge IPX. Now the question is, do I need to bridge IP as well? Do I need to bridge IP? Think about that. Look at that topology. What do you think? Do I need to bridge IP? I mean, we've got the BVI interface. They should be able to go to that interface and reach each other, right? The answer is yes. I need to bridge IP. Why? Well, because are these computers ever going to reach for that bridge virtual interface when they're communicating with each other? I mean, would this computer with 172.16.5.5 think it has to go to the default gateway to reach that computer? No, it thinks it's on the same subnet. It's on the same segment. So its next step is going to be sending ARP messages. And unless you type in the command bridge IP, which is in there by default many times, it will not bridge IP together, and these two segments will not be able to communicate using TCP/IP between those two. The other command is the bridge 50 route. This now says what protocols are routed. Now you remember, let me see if I've got in my scroll buffer, when I first typed in that command, there it is. When I first typed in bridge IRB, it said generating bridge 50 route IP configuration command. So it already, let me get back to my syntax here, it already typed in bridge 50 route IP, which tells that BVI interface you will be able to route the TCP/IP protocol. Some iOSs don't do that. Some iOS versions. So get in the habit of typing this command anyway, just to make sure that that will accept IP. Also, you get to say if you wanted to route any other protocols. If I wanted to route IPX, I can go ahead and say bridge 50 route IPX, give that BVI interface an IPX address, and it should be good to go. Now I can verify all of this by typing in show interface IRB. And it will show you all the IRB interfaces that it has right here. And it will also show, you can see a lot of the MAC addresses that it's generating and using for You can see right there, that's the MAC address it generated to use for that BVI interface that we made up. But this is the important stuff that I'm concerned with. Routed protocols and bridge protocols. Now, I did type in routed protocols as IPX, but it's not going to show up here until I give that BVI interface an IPX address. Notice it also bridges many of the other protocols, CLNS and DECnet, by default. So if you don't want those in there, you can type in a negative form of that command using the no syntax. But at this point in time, we are good to go. That interface, IRB, is up and running, and we should be able to route from these computers to any other part of the network. It's now seen as one subnet. The cool thing is that you can also create BVI interfaces and do all of this on a 3550 switch, which is one of the primary switches you'll need to understand. So you can actually bridge VLANs using the same technology. Use a transparent bridge between those VLANs, create a BVI interface to link those VLANs together. Now you might say, well, Jeremy, why would I ever do that? Why not just eliminate the VLANs and have one single VLAN for those? Well, I had the same thought, but that might be something crazy enough for them to ask you to do on the CCIE lab. So I'd be very familiar with how to do this same setup. It's the same command, same config, but you can just do it between VLAN interfaces. Now let's talk about the IP helper address command, and I'd like to give you a great story to go along with it. The IP helper address command is a powerful command related directly to the TCP/IP protocol. Now, we've been talking about bridging in a broad sense. Transparent bridging essentially takes an entire protocol and forwards it to another segment. It takes the walls of the router completely away for broadcast-based protocols like IPX, like AppleTalk, like things that aren't TCP/IP. But since most our network nowadays use IP, the IP helper address is a less devastating way to move those walls of the router away. Instead, we just poke holes through that wall and we say, well, I just want to allow some broadcast traffic through. Forgive the Cheesemo graphics, but it goes along with the story that I have of IP helper address, which I'm sure many of you have heard about, but let me kind of spin it to you in a new way. I did some work a couple months ago for a healthcare company, and I'll tell you what, it was such a cool job. I should have been paying them to work there. They were moving an entire 3Com network completely over to Cisco's Catalyst 6513 platform, and they just had these things decked out with blades. Now, this healthcare company, the idea that they had was ingenious, and they were being picked up by a lot of insurance companies. What they did was they had a bunch of registered nurses, I mean hundreds of registered nurses in this location, and what would happen was insurance companies would give all of their people, all of their members, a number to call before they ever went to the doctor, before they ever went to the hospital and started ringing up a huge bill for the insurance company. They could call a registered nurse 24 hours a day and get them on the hotline and talk to them to make sure that they had to go to the hospital or they had to go to the doctor before they actually went. And the insurance companies loved it because they don't get hit with the bills. The customer loves it because they don't have to leave their house if they're not really sick. The reason I tell you this story is because I was setting up VLANs for these nurses and putting them all in separate VLANs. Now, initially, this seemed like a great idea because there are hundreds of nurses there generating a lot of traffic, and the company wanted me to split them up into VLANs until they showed me one application. Now, I'm sure you've heard of the net send command. It's a command that you use from a DOS prompt. If you haven't used it before, just open a DOS prompt and type in net space send space and just hit question mark and you'll see all the options. It was my nightmare in classroom training because students would constantly send messages to each other on their computers. It's a broadcast-based protocol that essentially uses the UDP port 139 to send just a broadcast of message to whatever person you would like to send it to. Now, these nurses had an emergency icon on their desktop, and here's the idea. If a patient called in and said, you know what, I'm not sure if I should go to the hospital, my heart's and starts having problems, the nurse can immediately hit this icon on their desktop, and it uses the net send protocol for actually a good use. It sends it to the entire building and says the nurse at station blah, and fills in their name, is having a problem. Everybody converge. So all the nurses come around there so they get the whole wealth of knowledge. Well, here's the problem. I've got this Catalyst 6513. It has VLAN interfaces just in the same way that your 3550 does. It runs the same native iOS. And when they ran that netsend command, guess where it went? You got it. Only to nurses in their same VLAN. So only a certain subset of nurses would get the emergency message, and it needed to go to everybody in the company. So what you're able to do is to use the netsend command to enhance this capability and choose certain ports to go through the Catalyst or your router depending on what environment you're in. Let me show this to you. Since the switch is in native mode and running the standard iOS, the commands are the same whether you're on a router or a switch. So I'll jump on my router 1, and the only difference is on router 1 I'm going to be going under different types of interfaces. The Catalyst has VLAN interfaces, whereas this has real interfaces that we're used to. So let's say I'm receiving broadcasts on Ethernet 1/0. In order to forward them using the IP helper address syntax, we just go under that interface, and I'll type in IP helper address, followed by the IP address of where I want to forward them to. Now, many of you have probably seen this command used in the sense of a DHCP server. We have DHCP clients on VLAN 30 and the DHCP servers on VLAN 20. So I will say all the DHCP requests will forward directly to the IP address of the DHCP server. That's the most common use of it. But that's not what I wanted here. I wanted anything, and let me jot the port number on here for you. The netsend command uses UDP port 137. So I wanted any broadcast coming in on any one of these VLANs to port 137 to forward to all other VLANs, but I don't want any other broadcast traffic to go through. How would I do that? I mean, I'm not sending it to a specific IP address. This is my quandary. This is what had me thinking for a while on this one. Well, here's the idea, and this might give you a hint if you haven't thought of it already. Please ponder this one, because it took me a while. These are subnets of 192.168.1.x over there. This is .2.x and .3.x. Okay, with 24-bit masks. So what I did is I went ahead and typed in IP helper address, just like this, and then I typed in 192.168, and we'll say I'm on the interface VLAN 30 over here, .2.255. You see that? What address is that? That's a broadcast address for that whole subnet. I'm taking anything that I get in, and I haven't showed you how to specify just that port, but I'm taking anything that I get in on that port and sending it to the broadcast address of those two subnets. Now that also brings another problem in here. As a security measure, that is considered a directed broadcast. By default, the switch and the router most often will have a command in there typed in no IP directed broadcast. So under each interface, I actually had to type in IP directed broadcast so it would allow messages to that IP address to come through. That's the second command. That's not normal unless you're doing an IP helper address to a broadcast address. I did that for each one of these VLAN interfaces, but now I need to tell it, you know what, I don't want a bunch of broadcasts to go through. I just want that one port number, which is not forwarded by the helper address by default. So that's where the second real command comes in. It's a global command because it affects the router globally. It's called IP forward protocol. And right here I get to say what protocols are forwarded. Now the helper address by default will forward a lot of protocols. There's 8 of them actually. There's TFTP, there's DNS, there's the time protocol, there's DHCP, it'll forward DHCP requests. There's a bunch of them. You can check the online documentation for all of them. But I didn't want those, so what I did was I typed in no IP forward protocol and then the UDP port number of each one of those. Then I followed it up with IP forward protocol, UDP, and you can see it lists the common ones, but I wanted that one right there, NetBIOS name service or 137. Okay. By doing that, that scenario is now complete. The nurses, once I did that on all the VLAN interfaces, the nurses could execute that application. It would send a broadcast to 137. The helper address, which is the whole concept I want you to grab here, the helper address would grab it and then send it to the broadcast address of those other two VLAN interfaces, depending on what VLAN interface it came in. So what I wanted to do is, I know a lot of you have seen the helper address before. I wanted to expand what you knew about the helper address and give you some scenarios that you may encounter in different scenarios, not just the CCIE lab, but all over the place in the real world. Whew, I'll tell you what, that stuff just gets me revved up and going. I could talk about that all evening, but I won't. Let's go ahead and wrap this up. Advanced Router Technology Part 1, talking about the routing bridging technology. What we've covered is, number one, transparent bridging. Literally removing the walls of your router and allowing certain protocols to be bridged, just like a switch does, to different areas of your network. And you can specify those using the bridge group command. We then talked about integrated routing and bridging. Very easy to enable that one command, bridge IRB. And then you can go under the interface for the BVI, the bridge virtual interface, and create this virtual interface that all the bridge groups are able to reach, or all the interfaces in a bridge group is able to reach. Finally, the other way of transporting unroutable protocols, or protocols that should not pass through, is the IP helper address, to forward some of those selected broadcasts through your network to either a specific IP address, or, as we just saw, we can even forward it to a broadcast address on another subnet, to really kind of combine a transparent bridging style of technology with the IP helper address. I hope this has been informative for you, and I'd like to thank you for viewing.